This is a mountain. Why am I talking about a mountain? Well, if you think about it, to render a mountain, you need a shader. In fact, to render anything you see here on the screen, we need shaders. And you might think you just need maybe a few shaders, right? To represent all the scene. Maybe you are just using the standard shader, or the URP standard shader, or the HDRP lead shader. Who knows? That's not the point. The point is, you think you are using just a couple of shaders, but Unity is generating thousands of shaders for you. If you knew about that, you know that this is a problem for your game or for your project, for that matter. It is a problem because the more shaders that Unity generates for you without you knowing that, because it's automatic, the more draw calls that your application is going to have. And not only draw calls, it's going to also cost you more GPU time because of the shader switches that happen in real time, and your compile times that might, just be increased by 20 minutes, and your loading times, which might go above 1 minute. Is that bad for your project? You guess. And we are not done yet, because this can also increase your memory usage by, let's say, 100 MB, depending on your project, which means that your operating system will kill your app earlier. So yeah, more chances to gain the lottery of getting kicked out of your operating system's memory. Is that a lot of fun to deal with? No. And I bet that your users will not like that and will punish you because of this. Yes, it is true. I'm always saying this. They will probably put you a negative review and, ask for their money back. And you don't want to end up paying for a game that you worked for 2 years on, right? You actually want to get money from your game. All right, so one way to make sure this doesn't happen to you is to know what the concept of shader variants is. A shader variant is just one shader that Unity creates for you. Now, you might think that you are just using a few. After all, you have all your materials here, right? Let me open just one here, for example. And, here we are using the standard shader. So if that is the case, we only have one shader. No, that is wrong. Because when you use shaders and in your materials in Unity, depending on the configuration of that material, that might end up being a different shader than the one that you thought of. The reason for this is that, for example, if I delete one channel, like the occlusion channel, this is surely a different shader than another material with the exact same parameters that has the occlusion map. Those are two different shaders, right? Or to be more accurate, those are the same shader but have two different shader variants. And let me tell you that your GPU doesn't care about all of this crap. The GPU just wants shaders. And in this case, you will be giving the GPU two different shaders. And for that, you would need to force the GPU to change shaders every time that you render objects that have slightly different materials, even if they're using the same shader. Does it make sense? The reason Unity does this for you is because otherwise you will need to completely write a new shader every time that you made a slight adjustment to your materials. And that wouldn't be a lot of fun either for you. It wouldn't be productive. You will end up spending most of your day writing different shaders just because they have slight variations. Okay, so this is the reason that Unity does it. It is not an evil thing. The evil comes from not knowing about this fact, about the fact that different materials using the same shader might end in having, two different shaders at the end. And that is super expensive, really. This is one of the most expensive things you can do in terms of not batching, right? Every time that you draw an object, if you have to change the shader, that's going to be super expensive. It's going to slow down your GPU quite a lot. And like I said, that's also going to be not great for your memory usage, for your loading times, and compile times either. So having said that, what can you do about that? There are two steps in order to fix this problem. The first one is to gain awareness of when this is happening, right? To gain awareness of the shaders that you are actually using and producing for the final build. That's the step number one. Step number two is going to be to actually get rid of the shader variants that you don't necessarily need. Okay? The fewer shader variants that you end up with, the faster that your projects will run in your target platform. Run, load, all of these things, right? So how do you do these two steps? The first step is to, again, realize which shaders you are using. And for that, you need to go to the player settings. And this is the way that I normally suggest my clients to use. Then you go to graphics, and at the end, you can just click this option that says log shader compilation. Okay, that is a way for Unity to tell you which shaders you are using in your end project. So you tick this checkbox, and now what you need to do is, of course, to make a build, right? For your target platform, this is important. So let me just do one build, in development build, of course, okay? Let's see what I get. Ooh, nice. I love it. Good, enough. Let me close this. And now let me open this log file. And we should open that with Notepad. Go away. I don't want to open that with Notepad. Let's open that with Visual Studio Code, and please, forever. Okay, now we are in the juicy part of the first step. You see all of this? Compiled shader. You see how many shaders you are compiling, and you thought it was only one or a few? That's not the case. Here you will see not only the shader itself, but also the shader variants, because it is the combination of all of these parameters, right? It is about the stage, it is also about the keywords, it is also about the type of shader and all of this, right? So here you gain awareness of the shaders that you are producing. The more of these shader variants that you have, the worse, because that's going to eat all the performance metrics that we were talking about. All right, second step. Let's assume that you found one shader, or hopefully 90% of the shaders that you want to get rid of. Second step again, get rid of the shader variants that you do not need. How do you do this? For this, I normally suggest two options. The first option is to use the Unity API. The Unity API has a nice thing called, yes, I trust you. Time for a break. Thank you. The Unity API has a nice thing called I preprocess. Rather, come on, help me. There it is. I preprocess shaders. And the thing that it does is to let you know when Unity is up to compiling a specific shader variant. Okay, and here, depending on the conditions that you have in mind, you can tell Unity, no, please abort, I don't want this shader in my build, or yes, I want this shader in my build, right? So you get all of this information through this callback. Of course, this script has to be an editor script. You want to put this in the editor folder, right? There is a process to do all of this, but this is the starting point. This is the starting point for the first option. The second option is to use other tools. I'm talking about tools like SIGTRAP, Shader Stripper. Oh, what is this magic? Here you can create assets that tell this tool which type of shaders you want to get rid of, right? Let me see if I can show it to you. SIGTRAP, here it is. So you can also just say, I want to exclude all the shaders that are in this path, right? You can create a blacklist, and then you fill it in with the pattern, and at the end of the day, the shader stripper is going to kill these shaders that you specify for you. So those are the two options. But before you forget everything that I just said, there are two steps. First, find which shader variants you are using, and second, kill them all. Okay, not all of them, but the ones that are annoying you. Because let me tell you, if you get rid of 60% of that, not only your draw costs are going to be fewer, but they are also going to be much cheaper, which is always nice. Your GPU cost is going to dramatically decrease because you switch between fewer shaders, and all of the rest of the things that I have been talking about, all of the other metrics are going to improve. Memory usage, loading times, and compile times, and maybe more of them, but I just forgot. If you want to see the entire process and how do I actually do this, then join the Unity Performance Task Force. You can find this lesson in the membership area. It's going to be in the lesson number 6 of the Unity Performance Task Force. You can join for a trial. No hard feelings if you do not stay, but I'm sure that you will, because you will like a lot the membership. Just join, the link is below, join the trial, and then go to the lesson number 6 where I walk you through the entire process. And of course, I explain to you all of this in detail without time limit. I hope this video was useful for you. Take care. See you next time.